Hi, this is Roopa Prasad, Department of Computer Applications, MITS College. Okay, so today we are going to discuss about data encryption standard, so which is a symmetric cryptographic algorithm. Okay, so before going to before going to discuss about the data encryption standard, first we will discuss about the Fiesel cipher. So, which is the base for the DES algorithm. So in this Fiesel cipher, we are going to use two techniques. One is called as a substitution and the one is called as a permutation. Okay. So substitution means what we are going to do in the substitution technique is each plain text element will be replaced by the another element, another corresponding ciphertext element. That is a substitution process. Where coming to permutation, that is nothing but the transposition. That means we are going to change the position of the plain text elements in the ciphertext. We are not going to replace by any other element, just we are going to change their positions. Okay, so first we discuss about the Fiesel structure before going to the DES algorithm. So Fiesel cipher structure. So here we have both encryption process as well as the description process. So here what happens, this structure is very important because for the DES follows this structure only. So first we will discuss about this structure here. So this plain text, so whatever the plain text which we want to transform will be divided into two halves, the left half and the right half. So this right half will be given to a function. On this function we are using a key called as k1. So the output of this function becomes the right half. The output of this function is XOR with the left half and it becomes the right half. Okay, and this right half becomes the left half for the next round. This is the scenario how we are going to follow in the Fiesel cipher in rounds. Okay, so what happens, the input text, that is a plain text, the plain text is divided in two halves, two equal halves. One we call it as a left half and second we call it the right half. This right half, that is this right bits are sent into a function. On this function we are using a key. Okay, the output of this function is XORed with the left half the previous round to become the right half in the next round, and this right half becomes a left half. Okay, and that will be given for the next round. The next round also follows the same structure until the last round. And the last round, what happens, the this right half becomes a left half and left half becomes the right half. Simply we are going to swap, and that we call it as output ciphertext. Okay, in Fiesel structure totally we are having 16 rounds. On each round we are using a unique key called as unique key. That is K1 to K16 keys we are going to use. That is the encryption process in the Fiesel structure. This Fiesel structure is very important. Why? Because in DES we are following this Fiesel structure. Once again I will tell you. The plain text will be divided into two equal halves, left half and right half. This right half is given to a function. So on this function we are using the key. So it generates the output. That output is XORed with the left half to get the right half. Okay, and this right half will become the left half. That will be input for the next round. In the next round also same scenario follows up to the last round, that is the 16th round. 16th round we get the output. This output has to be swapped in order to get the output. That is called as a ciphertext. That is the encryption process. And this is a theory for the encryption process which we have explained, and this structure follows the substitution permutation network proposed by Shannon. Okay. So we come for the description process, decryption process. Here decryption process is inverse of encryption, but here what we are going to do is we are going to, the input for the decryption is ciphertext and output is the plain text. Whereas in encryption, the input will be the plain text and output will be the ciphertext. Here the input is a ciphertext and output is the plain text. That is the inverse of the encryption process. So here also same thing, the input is divided, in the input ciphertext is divided into two equal halves, that is left and right. This left is right is given to a function. Upon this function we are going to use a K16, that is the last round key is used in the first round, that is a decryption process. So in the encryption process on the first round we are going to use a key 1, but here what we are going to use, we are going to use key 16, that is the last round key. So the output of this function is XORed with the left half and it becomes the right half. This right half becomes the left half for the next round. Okay, the process continues until the 16th round, that is last round. At the last round, we are getting the output. That output will be swapped. That is, a left will be swapped to right, and right will be swapped to left. That is a process. That is a decryption process, which is going to happen in the Fieser structure. That's what we have discussed. Okay, then we come for this Fiesel structure. This is mainly following based on the following parameters. The Fiesel network depends. One is called as the block size. That is, what is the size of the block text we are going to take. So if there is a larger block, that means they have a greater security. But encryption decryption process speed will going to be reduced. So generally we are going to use the block size as 64 bits. That is, this 64 bits is divided into two halves. That is, a left 32 and the right 32. And key size also plays a major role. So for this key, the normal size will be 64 or less we can use, but nowadays 128 bits are become more common. Okay, and then number of rounds also plays an important role. So if there are more rounds, there will be more security. Generally, the typical rounds are 16. So then sub-key generation is also very important, and round function is very important. If it is the round function is complex, there is a greater security for the Fieser cipher. Okay, then we come for the data encryption standard that we are going to discuss today. Data encryption standard. So it is an encryption algorithm. This is a symmetric encryption algorithm. Okay, what we say, it is a symmetric key block cipher. So we are calling it as a block cipher. Why we are calling it as block cipher means, so here the plain text upon the plain text is treated as blocks. Upon the blocks only the encryption algorithm will work, and we are calling it as a symmetric key. Why? Because it is a only a single key is used for both encryption process and the decryption process. So DS algorithm is a symmetric key block cipher algorithm. This algorithm has been published by NIST, that is National Institute of Standards and Technology. And this DES follows the Fiesel cipher. That's what we have discussed, the Fiesel cipher. It implements the Fiesel cipher. The DES algorithm implements the Fiesel cipher. So in this DES algorithm, we have 16 rounds and the block size is 64 bit. These are the main things we have to remember. It follows a Fiesel structure and we are having 16 rounds and the block size is of 64 bit and the key length is 64 bit. Even though the key length is 64 bit, we are going to make use of 56 bit, that we will discuss later. Okay, so the key size is 56 bit, block size is 64, and we are having 16 rounds, and this is the implementation of Fiesel cipher. So this DES is a symmetric key block cipher algorithm. Symmetric key block cipher, because the algorithm is going to operate on the block, so we are calling it as a block cipher, and it belongs to symmetric key. That is, cryptographic algorithms are divided into two. One is called as symmetric and the one is called as asymmetric. If only one key is used for encryption as well as the decryption, if we call it as symmetric. If a pair of keys are used, we call it as a asymmetric, and this DES is an example of symmetric key cryptography. Then, so here in DS we have the 16 rounds. In each round we have the substitution followed by permutation. Okay, so the fundamental building block of DES is the combination of substitution followed by permutation, that is based on the key. And this is a general structure. Okay, this is the overall structure of DES algorithm. So what is the input for this DS algorithm is 64-bit plain text. So we are operating at a block because it is a block cipher. We are going to operate on the block. So the block size is 64-bit. So here we are having 64-bit plain text, which is the input for this DES algorithm. So in the DES algorithm, first what we have to do, you have to go for the initial permutation. So in the DS algorithm, we are having the 16 rounds. Before giving the plain text to the round one, we are going to perform initial permutation. The output of the initial permutation is given for the round one. On each round, a separate key will be used, that is a 48-bit key, which is generated from 56-bit cipher key. So the key size is 56-bit. From this 56-bit key, we are going to generate 16 48-bit keys. Okay, we are having 16 rounds. So for each round, we have a unique 48-bit key that is generated from 56-bit key. Okay, after 16th round, we have to do for the final permutation. which is the inverse of the initial permutation. The output of the final permutation is a 64-bit ciphertext. Okay, this is the overall structure. So the input for this algorithm is 64-bit plain text and the output is a 64-bit ciphertext. First, the plain text is given to the initial permutation. After initial permutation, the text is given to the round 1. On this round 1, from round 1, it goes to round 2, like that it goes to round 60. On this, each and every round, a unique key will be used that is generated from 56-bit key. From 56-bit cipher key, you are going to generate 16 48-bit keys. The output is last round output is given for the final permutation, which is the inverse of initial permutation. Thereby, we are getting the 64-bit ciphertext. So this is a notes regarding to this one. Here we are following the feature structure. So this function follows a feature structure. That means what? The 64-bit plain text is divided into two halves. One is called as a left 32 and right 32. So that's right 32 is given to a function, that is a round function. So which will make use of that key. So the output of this function is XORed with the left 32 bits in order to produce the right 32 bits for the next round. Okay, and right 32 bits becomes the left 32 bits for the next round. That is a feature structure. So this DES algorithm follows a feature structure. And what we discussed in the feature structure, we have the initial and final permutations and we have the round functions. 16 round functions are there. So initial and final permutation or straight permutation boxes. That is, transposition is done in the initial permutation and the final permutation. Final permutation is the reverse of, that is the inverse of initial permutation. And these permutation have no cryptographic significance in DNS. Thus, they are going to transpose the bits. Before going to give it to the round function, we are going to transpose the bits based on the P box. Okay, so this P box is predefined. Based on this P box, we are going to transpose the bits. So this is not having any cryptographic significance. Round function is the main thing. In the DS algorithm, round function is the main thing. So this DS function applies 48-bit key to the rightmost 32 bits to produce the 32-bit output, what I earlier said. Okay, it follows the feature structure. That means what? The 64-bit plain text is divided into two halves, left 32 and right 32. That right 32 is given to a function. On this function, we are going to use the 48-bit key generated from 56-bit key. Okay, in order to produce the output that is XORed with left 32 and it becomes a right 32. Okay, and so coming to this round function. Okay, so what happens in the round function? Okay, we already discussed. So the plain text is divided into two halves, left 32, right 32. This right 32 is an input. Okay, so this is a round function which is the heart of the DES algorithm. So this right we have the 32 bits. So that in this round function we are using a key which is of 48 bit. So we are having 32 bit. So this 32 bit has to be expanded to 48 bit because we have to perform the XOR function. So we are going to use the expansion P box. Okay, in the round function, we are going to use the expansion P box so that the 32 bits are expanded to 48 bits. Okay, that is a permutation box. We are going to extend this 32 bit to 48 bit so that it can be XORed with the key. Okay, after XORing, we are getting the 48 bit key. Okay, this 48-bit key has to be given to the substitution box. This is permutation followed by substitution. In the substitution S box, we have 8 S boxes are there, or 8 X boxes. So in this this 48 bit will be converted into 32 bit. Okay, these are replaced by 32 bits S box. We are having the predefined S boxes. So by using this S box, we are converting the 48 bit to 32 bit, and this 32 bit will be sent to the straight P box. That is the permutation which are going to transpose the bit. The 32 bits are transposed to get the output 32 bits. Okay, so from here onwards, what happens? This 32 bit is XORed with left 32 in order to become the right 32. Okay, you have to remember that physical structure. So the plain text is divided into left and right. Right is given to the function. The output of the function is XORed with left to becomes a right 32. This is a round function. This is the important in DS algorithm. So we are having three. One is called as expansion P box. It is having the functionality that it is going to expand the 32 bits to 48 bits. Okay. In the substitution box, we are going to replace. We are going to make the 48 bits to 32 bits. Then we have a straight P box, that is a permutation box, which we are where we are going to transpose the bits, which becomes the output. And the next, the important thing what we have to discuss is key transformation. So what is a key we are having? We are having 56-bit key. So from this 56-bit key, we have to generate keys for 16 rounds. That is round key 1 to round key 16. We are having only 56-bit key, and each key is having 48-bit. So how we are going to generate the keys means by using this one. Okay. So actually the key size is 64. Actually the key size is 64, which includes the parity bits also. But we are making use of only 56. What happens? This parity bit will be dropped. Okay, 8 parity bits will be dropped from 64 bits, so that the key size will be for 56. That we call it as cipher key. So what happens? This 56-bit key is divided into two halves, 28 bits and 28 bits. Okay, this 28 bits. Then the 28 bits are perform left shift operation on the 28 bits. Okay, and this left shift is performed the right 28 bits, and they are given to a compression P box. So here the key size is 56, but we have to generate only 48 bits. So this compression P box, that is compression P box, compresses the 56 bit into 48 bit, and that will be given for the round, that is the unique sub key. Okay, after left shifting, this again this will be shifted, and this also be shifted and given to compression P box, so that it produces a 48 bit, which is given for round 2. Okay, how many shifts is performed depends on rounds. Okay, for example, in round 1 2 9 6, only one bit will be shifted left. In other rounds, two bits will be shifted. Based on the rounds, the shift will be done. So that is a key expansion, how we are going to expand the 56-bit key into 1648-bit key, so that it can be given for each round uniquely. So that's a DES algorithm that we have discussed. Okay. So once again, I'm telling this DES algorithm is a symmetric block cipher algorithm, and it is published by NIST. So it makes use of the Fizzle structure. It is having 16 rounds. The block size is 64 and the key size is 56. Okay. From the 56-bit keys, we are going to generate 48-bit 16 keys, 16 48-bit keys. So this is a algorithm that is a symmetric cryptographic algorithm, and this material has been prepared from these references. And if you have any feedback, you can contact. Okay, thank you. Hope you understand. Thank you.